Okay, so the power rule for logs is this one. If I have log to the base b of a to the power of n, that will give me n times log to the base b of a. And I think this is what makes solving our log equations, why using a log is so useful in solving exponential equations when your variable is in the exponent, because it allows you to bring your exponent from up here to down in front of the line, and it's just a multiplier, and then it's easy to solve. Okay, so here's our proof for this. We let x equal log to the base b of a. If that's true, then it has to be true that b to the power of x is equal to a. Okay, so I've got this statement which we know is true. B to the x is equal to a. So I'm going to do the same thing to both sides of this equation. Raise both sides to the power of n. And they're still equal. Exponent laws. When you have a power to a power, you multiply exponents. So b to the n times x equals a to the n. Then I'm going to take this, which is an exponent form, and I'm going to write it in log form. That is, my base is b, so I have log to the base b of a to the power of n is equal to is equal to n times x. Exponent form, log form. I used the base b, which meant nx was the answer. A to the n is saying to what power do I raise b in order to get a to the n? I raise it to the power of nx. And then we're going to substitute. Log to the base b of a to the n equals n times x. Well, log to the base b of a to the power of n is equal to n times, what's x? It's log to the base b of a. And there's our proof. So, if I have a question like this, if I need to simplify, log to the base 10 of 5 to the power of x, this is the same as x times the log of 5. Log of 5, just a number. Or if I have something like log to the base 2 of 8, then I could write 8 as a power of 2. That's log to the base 2. Instead of 8, I'm going to write 2 cubed. My power law says that this exponent can come down in front of the log. So that would be 3 times log to the base 2 of 2. And we all know what this is. What's log to the base 2 of 2? To what power do I raise 2 to get to? So I get 3 times 1, which is 3. Simplifying my answer. Okay, I'm going to go quickly because we need to get through this change of base law. And then you'll be set for all the homework. So your change of base law is this. If I have log to the base b of a, that will equal a division. We've got the log on the top, the log on the bottom, because that's how we roll. A goes on the top, b goes on the bottom. Change this to any base you want. I think I'm not going to do the proof because we'll run out of time. Let's just do a couple of examples. Log to the base 3 of 7. To what power do I raise 3 in order to get 7? I'm going to change the base so I can use my calculator. I'm going to do log over log. 7 goes on the top, 3 goes on the bottom. I'm going to use my calculator. This is a base 10. Plug it in. What do you get? You guys getting 1.77? So if I take 3 and raise it to the power of 1.77, I get 7 for my answer. Make sure that when you enter this in your calculator, you put in the log, it opens a bracket. Close the bracket before you do the division sign. Okay, I'll give you one more to try. What is log to the base 4 of 128? And I'd like you to do this with no calculator, but using your change of base law. What's a good base to change it to? 2. Go ahead and do it. Are you all getting 3.5 for your answer? Okay, so are we able to do this change of base? Looking at the pattern here, you know where to put the 4 and where to put the 128. Okay, then here you're asking yourself to what power would you raise 2 in order to get 128? I use my fingers. 2 times 2 is 4, 8, 16, 32, 64, 128. The power of 7. Is that what you're getting? Okay.